Alright guys, so in the last video we really talked about the theory of how limits work. So we really kind of learned about what limits are and then different ways that we can calculate limits. Now this is just the first section, so we're just learning the basics. But in this video what I'm going to be doing is kind of showing a few of the problems that you might encounter in your homework and possibly even on an exam. And so this problem is the first one that we're going to go over, number 6. And it's a different approach to solving a limit than we might have been used to, as far as just looking at it or maybe using numerical values, even though we'll get to that. Because here we're looking at the graph. And so here we have this graph. It's kind of weird. So on the left side, it has this value that it starts going from the left side and then it swoops all the way down to what looks like a negative infinite value. And then that hits at x equals 0. And then going on this side, it starts at a positive infinite value, swoops all the way around, right around 1 or so. That's just an estimate, and then goes out and looks like it's going to even out on the x-axis. Now that's just an assumption. I would guess the function of this graph would be similar to y equals 1 over x, because it looks very similar to this. Now it could just be like a constant value multiple of that, but it's kind of the same sort of concept. And so with this one, what we're supposed to do is we're supposed to just use the graph of the function and then try to determine all these values. So we want to determine what the limit of the x as it approaches 0 from the left side, and then we need to find a limit as it approaches 0 from the right side. And then using those two, then we can kind of try to determine what the limit as a whole is. So let's think about it from the left side. So here we don't really need to do any calculation at all. So we kind of see it as it goes from -3 to -2 to -1. But you see here how as the closer and closer you get to 0, it goes more down, down, down towards negative infinity, right? And one thing that you'll find is if you have to put in numerical values, now we won't do this for this problem, but you'll find that the values will become smaller and smaller and smaller, and it's actually going to go to negative infinity because it's going to go all the way down as this arrow goes down, all the way down, and it's never going to quite hit the y-axis, but it's going to get really, really close. So this value we're going to say is going to be equal to negative infinity. All right, let's do problem B, which is basically approaching it from the total opposite area. So let's start approaching it all the way from this positive infinity on the x value. And so it's pretty close to 0, goes a little bit up, and then it swoops really high as a probably around 1 or so, and it's going to keep going up and up and up and up, and we're not going to do the numerical values, but it's going to go all the way up to positive infinity because it's going to keep going higher and higher, but not quite hit the y-axis from the right side. And so this value is going to be equal to positive infinity. All right, and the last one, this one's kind of tricky because we want to find the limit as x approaches 0, but as you approach 0 from the left side, like we did in the first part, it goes to negative infinity. And when you approach 0 from the right side, it goes to positive infinity. So what is the value? And then you actually find that if you take the function at that value, it's actually equal to 1. So what is the limit? Well, one thing we know is this point is not really meaning anything. When it comes to taking a limit, you don't take the value itself at the function. That doesn't even matter. What you take is the values that you approach. But what's tricky here is that you approach two different values depending on how you approach the limit. And so actually this limit is undefined. It does not exist. So I'm going to write DNE for does not exist. It's pretty standard because it approaches two different values from two different sides, and that's one of the properties that we learned. And since that's true, then the limit does not exist. So those are the different ways that you calculate that. And so just by looking at the graph, and obviously we're going to have different sort of examples based on what the graph says and what it tells you. But that's just by looking at the graph how we can answer these different questions. All right, so that's the first problem. Now, let's go to another problem. This one's a little more on the tricky side. And also we're going to be using different methods to solve this limit as opposed to the last one. Because you see here, we don't have a graph. And we could come up with one, but this problem is kind of really trying to teach us a different way to do it. So here we have the limit as x approaches 0 of the square root of 3 plus x minus the square root of 3 minus x all over x. And I don't know about you, but me personally, I have no idea what the graph of this is. Like, I couldn't even think of it in my head. Like 1 over x, or x squared, or x, or square root of x, those are things I could figure out. But this, it's pretty hard to attain. Usually I would put in my calculator and try to see what it is. But here, we're actually not even using the graph at all. What we have here is a table. And so what they want us to do is they want us to try to find a limit based on numerical values. And so the way you do it is you have these numerical values that approach whatever it is that you're approaching. In our case, it's 0. And then you're going to have ones that are very close to it. So you have negative 0.1, which is pretty close to 0, right? Then you have negative 0.01, which is even closer. Then you have negative 0.00, which is very close. And obviously, you can keep going with that precision. And then on the right side, you have 0.001, which is super close. Then 0.01, still close, but a little bit more outward. And then 0.1, which is farther out, but it's still pretty close. And so basically what they want us to do is they want us to fill this table. And I'm going to show in a later video of how exactly you can do this on your graphing calculator. Most classes that teach Calculus 1 usually require a Texas Instruments TI 83 or 84. I use an 83 when I took this class. You might use an 84. It has a few more capabilities. But since we're not using a graphing calculator, and since I'm recording just a screen and not my calculator, I'm actually going to go on a site called Desmos. You might have heard of this. And so I'm going to go on this. It's desmos.com. And what this site is basically like a graphing calculator, but with even more options, which is super cool. And so here, on this left side, we have this area where we're going to input a function. And on the right side, we have this graph. And what's really cool is when you start typing, for example, let's put in y is equal to x. They give us a really cool graph of y is equal to x, or y equals x squared. Then we have that, which is super, super cool. So let's try inputting our function, which is y equals the square root. So square root, you can actually do sqrt, and it's so smart that it'll understand what you're saying. Square root of 3 plus x minus the square root of 3 minus x, and we're going to do the whole thing over x. So I'm going to put parentheses around it, just like that, all over x, and we have this weird looking thing. And it might look like it just stops there because you can't really tell, but it's going to keep going way up there. But we're not really concerned about those end values. What we're concerned about is 0. And you see here the graph actually doesn't do anything weird at 0. So it's probably going to approach some sort of value in between 0 and 1, I would say. Probably around like 0.5, maybe just a tiny bit above it. But we don't have to guess here. We can actually do the numerical values. And so here we have the graph. But remember the problem. They weren't asking for the graph. They wanted us to input this table. And so what we can do is, in Desmos, there's this really cool option. If you go to the settings where it says edit list, you click that, and then you click this thing that looks like a table. It says convert to table. Click that again, and then we have this table right here. And so let's input all these values. Let's put input negative 0.1, negative 0.01, all the way to 0.1. So I'm just going to do this. I'm just going to do negative 0.1. And what's really cool is now auto corrects right here. Super cool. And then we have negative 0.01. And then we have negative 0.001. Then we have 0.001, 0.01, and then finally we have 0.1. So what's really cool is it inputs all these values, and the problem says that we need to have our answer correct to 5 decimal places. And so here you'll see that it's not going to approach some sort of clean value like, say, 1 or 2 or 0, or even a positive or a negative infant values. It looks like it's going to be like 0.577 something, right? And so here it shows we have, when it's negative 0.1, it's 0.57743, I would say. And then you have 57735, 57735, 57735, and it's actually very close to that 57735 when you get closer and closer to 0, and then it goes to 0.5774 as you get farther and farther away. So what I'm going to say, and venture to say, is that when it hits 0, that value is very close to 0.57735. And that's pretty much it. And obviously we could input this function saying those are different values. All you have to do is just you literally just copy and paste whatever those are. I don't think that's really necessary. And then you'll say that the value reaches around 0.57735. So that's the value that we propose that x is equal to, the y value is equal to as x approaches 0. And so we didn't do this by looking at a graph. We didn't do this using any fancy algebra or anything like that. All that we did is we just plugged that function in and then really just kind of observed what value it gets really close to. And that's pretty much all you do. That's how you do it. You fill in the table, you kind of observe, and then you see. And so in our case, this was actually pretty easy. There's nothing weird that happened. In other cases, you'll see that it'll go up super high, and then you know that it goes to infinity, or it goes down super low in the negatives, and it goes to negative infinity, and you kind of discern from that. But we had a pretty easy example. It was not too bad. But just so you know, in the future, if you're asked to use something like this, and then it does some weird things, then you can kind of use your gifts of discernment, I guess, to try to figure it out. But that's pretty much it right there. And let's go to our next problem. All right, so number 20. And so this is the last problem that I'm going to do in this video. Since we're doing 5 problems, and this is kind of a format that we're going to do for all the sections, I'm going to split it up in 2 videos. So the first 3 problems are pretty chill, pretty easy, not too bad. And the last 2 are going to be a little more on the harder side. I would say those are definitely not problems that you would expect like on an exam. But there are going to be a few of those stuck in your homework. And I feel like it would be beneficial for me to do those. And it's not like you have to know every single one, but at least you can kind of get a good idea of how to do those problems. But this is the last sort of easy one, I guess. So what we have is something called a piecewise assigned function. I'm sure you've seen these before, probably in pre-calculus or something like that. And we have f of x is equal to x squared minus 1 if x is not equal to 0, and 1 if x equals 0. And so the value that we're looking at, a, is 0. And so what we need to find is the limit as x approaches a from the left side, as x approaches a, which is 0, from the right side, and as x approaches a as a whole. So the easiest way to do this, in my opinion at least, is to draw a graph and kind of see what we have there. That's what I'm going to do. I'm going to draw a line for my x and for my y. There's that. And then let me draw this other line. Alrighty. So this is going to be y. That is going to be x. And so let's look at this x squared minus 1, right? So you know the x squared function is parabola that kind of goes like this. But since it's minus 1, it's going to go down 1 value. So this value is negative 1, right? And then you know that it's this if x is not equal to 0, which is interesting because the point is actually not defined right here. And so what I'm going to say is that there's going to be a hole right here, right? And then the function is going to go like this, like that function goes. And then it's going to go up like that function goes. Excuse my horrible parabola drawing skills, but it's going to look something like that. But you'll notice that when x is equal to 0, it's actually not right here at negative 1. It's actually at 1. So this value is going to be 1, and I'm just going to put a dot in. So that's how you do that. Because the function is defined right here at that point, but every other point is going to look like that. So that is a graph of our function right there. It's not too bad, right? And so that's what we have right there, and a is going to be equal to 0. That's the value that we're looking at. And then we're going to say, well, what is the value as x approaches a from the left side, right? And so just looking at the graph, right, you'll see that it goes closer and closer and closer to negative 1. Now, we're not concerned about where the function is defined. We're concerned about where it approaches, right? And so here, what we're going to say is that that value is going to be negative 1, just by looking at the graph. And now let's look at it as it approaches from the right side. So here, it's going to get closer and closer to negative 1. If you look at something like this, something like that, something like that, as it gets closer and closer, it's going to get closer and closer to negative 1. This is going to be the same thing. And now let's look as x approaches a as a whole. And here we're just kind of looking at both sides, from the left side and from the right side, and both sides approach negative 1. And now it doesn't matter that the value itself at negative 1 at x equals 0 is not -1. That doesn't really matter. All that means is that we don't have a continuous function. But that doesn't mean that the limit is undefined. It just means that the function itself is not continuous. And so here we're going to say, even though that the function is valued at this point, at this value, the limit is still equal to -1. And that's it. Not really too much to it. You just got to be careful that you're not really carried away by certain values that are other than what it's approaching, because you can clearly see that it's approaching this value from both sides. And that's really all you need to know. There's nothing really else that you need to be concerned with when it comes to finding a limit, especially by looking at the graph. So those are those 3 problems. In the next video, we're going to cover the 2 harder problems, I would say. They're going to probably take a little more in-depth analysis, and I would say don't be concerned about knowing everything about them, but I would say watch the video and so you can kind of get a good idea of how to do it, but you don't have to be an expert in it. But I would say these 3 problems that we covered, these are prime examples of stuff that will be on an exam. So I'd say definitely know how to do this and definitely know the logic that I'm using, and you'll be fine.